oh my god, I forgot everything about what we've learned, and you're not going to answer this correct. So take your time, take a deep breath when you get to these. They'll be the first questions on the exam. That's why I have them there, so you don't get panicked for time. The first ones you can practice this. They'll be like, I'll give you 2 of these problems. This one's tough. This one's not that tough.
What about 5?
5.
It's supposed to be, I think it's supposed to be one of the top.
I did. It was one of the harder ones. So it's 6.
Oh yeah, 5 is okay. 5 is pretty tough. You want to do this, or you guys want to go on to the other problems?
Yeah, I think we should.
We should do 5.
We spent 15 minutes doing all the doing
it's
this.
fine. Let's go to
I think we'll be okay. If
you
the other problem that we started with, you can look at that online tonight, and then convince yourself of the first one. Convince yourself that you can do it. That way, you'll be all confident.
9 wasn't that hard once you explained
for this. Balancing equations, we've done that. Let's talk about molarity. Lots of polarity with molarity. There's lots of questions I can ask about molarity. But the basic idea comes down to this. And you'll get this equation. Moles of whatever blank over liters. Now, here are the types of questions I can ask. I can say, if you've got the molarity and the liters, what are the moles? I can also ask, if I give you the molarity and the liters, what are the grams? Because you can turn the moles into grams.
Will you
right?
give us the conversion?
Hold on. Another thing I can do is I can give you grams and have you change them into moles, and I'll give you liters and I'll ask for the molarity. Or I can say, here are the grams and the molarity, what's the liters? So that way you have to change the grams into moles, liters. Or I can ask you the molecules. I can say the individual molecules. This is a tough one, by the way. We have not done one like this, but we could do this. Hint. Right? We could do this. Maybe it's like a really challenging problem. I'd say like individual molecules.
An extra credit question, maybe?
No, like a real credit question. Individual molecules of whatever, we can change that into moles, and I'll give you, I don't know, either liters or molarity, and you find the other one.
Will you give us the conversions for all this stuff?
What does that mean?
Like, will we get the conversion of molecules into moles?
No.
You won't put that.
How many molecules are 1 mole?
I'll give you this equation, molarity equals moles over liters, and molo equals min-lin, but you already know that, because you just told me.
How many molecules are in a mole?
How many molecules are there in the mole? You need that number?
That's
That number should have been
6.022.
tattooed on your brain by now. Yes. That's a
Wait,
mole.
then how many grams?
Tattooed. Get a neurosurgeon to tattoo it on your brain. I don't know if that'll help. I don't know. 6.022 times 10 to the 23rd. If you forget that number, I'll come over and I'll write it on your test and I'll make fun of you. Because we've learned that so many times that you should just know it by now.
If you want to turn molecules into moles, let's say you have 10 molecules.
Yeah.
So you do 10 parentheses.
Oh, you're trying to solve it right now. Let's not solve that yet. I'm just telling you the types of questions first. Okay? Another type of question I can ask you, which is a little bit easier, is I can give you liters in a different unit, like milliliters. So you have to convert the liters into milliliters, or vice versa.
If you give us like something like, I don't know, like high liters, but you give us the conversion for that?
Yeah.
So we have like one of those table things?
I can give you a conversion. The conversion I can give you is, the only conversion I'm going to do is 1,000 milliliters equals 1 liter. And that should help you convert from milliliters to liter. Okay. So that's all with this equation right here. Now, another equation that I have, and we're going to go through this, don't worry. Min-lin over there. Molo equals min-lin. So the molarity of the original solution times the liters of the original solutions equals the molarity of the new solution times the liters of the new solution. So if you dilute something, you need to use this. So it says Tommy starts off, or Alex starts off with so many molarity of, like, say, 6.5, and you have, like, I don't know, 0.5 liters. And I also give you how much it's been diluted. Now this is kind of tricky. Let's say that you dilute this to a total volume. This is the total volume here of, let's say, 1.2 liters. So you've increased.
Multiply that and divide it.
So you need to find what the molarity is. But this has tripped up so many people. It's tripped up you the other day. I remember this.
Yeah.
Where I said, just add, I don't know, like 5 liters to this and tell me what the new molarity is. Instead of saying what the final molarity is, I just say, add 5 liters. So you have to know, if I add 5 liters, then this final volume is going to be 5.5 liters. Okay? So that's a little bit tricky in the questions. So be wary of that. All right.
Wait,
do you
so
want
if
to
you
do
say
some
add 5 liters to the final liters, then we just add 5 liters to the final number?
So you have an original solution, right?
Right.
If you add 5 liters to
But
it, it's
you'll
going to
say
be
to add
whatever. It's going to be whatever the original solution is plus those extra liters.
And then the way to solve that is do 6.5 times 0.5 divided by 5.5?
That's just algebra right there. Or I could tell you what the molarity is.
Yeah, I wasn't very good at geometry.
That's
That's algebra.
Can we go over how to put individual molecules into moles quickly?
No, because then if we do that, then it's not going to be a really challenging question. I can talk about more about mole conversions, and that might help you.
I know how to do it.
We've just done this the last few days, so I don't know if we really need to go through some problems with this. If we can, if you want to. But I'm cognizant of the time. We've got 10 minutes left. I'd prefer to go over something we haven't gone over in the last week.
Okay.
Would that be okay?
Yeah.
Okay. Look at your quiz. Look at the worksheet I gave you yesterday, Alex. You're going to need it.
I wasn't here yesterday.
I know. You need to have, that's what I was about to say. You're going to need to have, I don't know where that went, that new worksheet. I've got extra copies next door. Oh well, we lost the orange. The orange is gone.
Yeah. What am I trying to look for?
You can still see a marker. It's not like it disappears because it's a color.
It's all black. The floor is completely black.
What color did you see the floor?
I don't know. What do you see there?
I found the green.
Oh, good job. Do you know it's green?
Yeah.
What's it? See, these are the same color.
No.
Yes, they are.
That's like what he says. Like, we were doing art, and I'll be like, give me like an orange marker. He's like a blue, and he's like, here's orange.
That's really mean.
Like, it's taking me 30 minutes to get a marker. He keeps giving me different colors.
That's really mean. Okay, so we did molarity. Let's do mole conversions. So this is the little mole railroad that we did before. So moles of whatever, blank. I'll just leave it as blank. And then we can have over on this side, what was it? Grams, I think. Grams. And over on this side, we'd have individual whatever. It could be individual molecules.
Oh, that's what this thing is? No, that's
Oh my goodness. Molecules or atoms. Or sometimes just things. Things. Hint. Things. Okay. So going from grams into moles.
You have to have 1 mole over the amount of grams.
So it's going to be it's going to involve the molar mass. So you can look that up. So let's just say that, for instance, let's say we have,
15.999,
let's say,
that's oxygen.
hold on a second. Let's use oxygen, fine. Let's say that we have 23.982 grams of oxygen. We want to convert that into moles of oxygen atoms. Okay? Moles of oxygen molecules. Sorry. So we want to convert that into moles of oxygen molecules. How are we going to do that?
23.982 parentheses 1 over whatever.
What is it?
15.999.
So 1 mole of O2
Over
is
15.
0.999 times 2.
15.999.
Yeah. It's a molecule.
Will you press that around
No, it's
oxygen's
like-
molar mass?
Oh, 15.999.2 of what? Oh, what is that? That's a mass of 1 mole of oxygen.
Oh, it's 1.498968.
That's not what he's asking. I think it's like 32 point, or it's 31 point, something close to 32. Oftentimes you just round to 32.
Okay.
Wait, what was he asking?
It's like 31.9.
He's asking what this
Oh, it's
result
like
is.
31.998.
Yeah.
Something like that.
So If you do that, that'll get you into the moles of oxygen molecules. Then, from the moles of oxygen molecules, if you want to go to individual molecules, what are you going to need to do there?
You do that number, parentheses, 6.022 e to the 23rd over 1 mole.
So this, wait, well, let's just get this right. This is going to be blank moles of oxygen molecules. So to go from moles of oxygen molecules into individual molecules, how are we going to do that again? Sorry, I know I just heard your answer.
You
But
do that number, parentheses, 6.022 e to the 23 over 1 mole, parentheses.
Oh, okay. So the mole goes on the bottom there. Mole of O2 molecules goes on the bottom. I'm just keeping this straight. And then this is going to be 6.022 times 10 to the 23.
Yeah, that's if you want to go moles of atoms into individual atoms.
Yeah. 6.022 times 10 to the 23. And this will
Shit,
be
no?
molecules.
No, you're right.
Yeah, no. You're right.
O2 molecules.
I have the right thing written down.
Okay. This will get you into the individual molecules of atoms or things or whatever. Now, the reason this works is because we have these things called conversion factors, where this right here, 6.022 times 10 to the 23rd, is in mole. Okay, so it's like a dozen, 12 is a dozen, so this number is a mole. So you can go from moles of whatever into the individual things, the number of individual things. You can go backwards too. Let's suppose we start off with a big number of oxygen atoms. How do we get back to moles of oxygen molecules? Let's do oxygen molecules.
You
How do
put
we get
the
that?
individual molecules, parentheses 1 mole over 6.022.
So it'd be 1 mole of O2 molecules over 6.022 times 10 to the 23rd O2 molecules. Good. Okay. That's it. And that would get you back over here to moles of oxygen molecules. Then from moles of oxygen molecules, you can go back to the grams using this molar mass over here. So it'd be the inverse of what's going on over here. So it'd be multiplied by 15.999 times 2. That's going to be in grams. And that's 1 mole of O2 molecules. This will get you back to grams. So you can go from grams to moles to individual molecules or atoms or things or whatever, and you can go backwards to moles and then back to grams. So the time that this is useful, the moles is useful for the molarity, is when you need to find moles, obviously. So you can start off with grams and convert it into moles, and then take those moles and divide it by the liters, and that'll be your molarity. You could also do individual molecules and turn those into moles. We haven't done a problem like that. And divide that by liters, and that'll get you molarity too.
So really the hardest thing here is the endo and exto.
Is that hard? Okay.
How many endo and
We
exto
practice this a
questions
lot.
do we have?
What?
How many endo and exothermic questions are we going to have in the test?
A few.
Like 1?
Like 2 or 3
Like 6.
Should I see how many?
times 5.
I
I
say
don't
we
know.
should have as many
I'm not gonna-
endo and exothermic as we should have the first thing that we did, the balancing equation.
Why?
Because I'm probably going to get all of these wrong and all of those right.
So you want to get more wrong.
Well, no, because if I guess, I'll put up 50% of this right probably, and I get all of those right. So I got a 75, like 5%.
Why was just why
That doesn't
not
make any
have them
sense.
drastically less when you get them wrong?
That would make more sense.
Fine. How about no endo
Fine.
and exothermic?
Yeah,
I want to hurt myself.
Here.
I'm not gonna hurt
Let's
myself.
come to a conclusion. I say we do no endo and exothermic, and you can leave that for next year's chemistry class.
Yes.
And we'll come to a compromise. Come on.
Says the kid who wants to take chemistry next year.
No, I mean next year's 10th grade class.
All right.
We're not gonna do that.
So that's good. Any other questions about anything that we've covered?
Can we go over more endo and exothermics to accept more limits?
I think that
You
they-
got five.
What about the reaction types?
Oh yes, reaction types. Oh, I almost forgot about that. So there's how many
Oh, I
reaction
don't know
types? You
any.
got 5 reaction types. Oh my goodness. Is there 5?